Let's look at the following simple Python code. In this code, we are creating a string variable called myWord, and we are storing the word hello inside of it. In memory, strings are actually arrays of characters. We will look at arrays in a later lesson, but for now, you can think of a string as a collection of individual characters that have a value and a position. The only thing to remember is that the position of the letters start at 0. You could also think of a string as a series of buckets on a pole. Each bucket has a number painted on the front that is its position on the pole. The position starts at 0. The pole is the name of the string. Inside each bucket is a single character. So, looking at this illustration, we can see that the letter H is at position 0, the letter O is at position 4, and the length of the word is 5 characters. Knowing how strings are stored in memory means we can do some basic operations on them. As mentioned, strings are held as a one-dimensional array, which we will look at in a future lesson, and all strings have letters in a specific position and have a length. The length of a string is simply the number of letters it contains. This table shows the word hello as a string of characters. We can see that there are 5 letters in the string. The length of this string is therefore 5. The Python code to get the length of a string and then print this length out is this. If you ran this code, you'd notice it says that the length of the string is 11, but you might think that it should be 10. Remember that empty spaces count as characters too. The length function is very common in password validator programs, such as where the password has to be longer than 8 characters. If we look again at the table from before, we can see that each letter has a position. For example, the letter at position 0 is H, and the letter at position 4 is O. In all strings we assume the first position is 0. This is useful for secret word validator programs where you have to input a password and then the program will ask you for the 2nd, 5th and 8th letter. We can also use the position of a letter to identify a substring. A substring is basically a sequence of characters within a string. A substring will usually have a start position and then the number of letters that the substring contains. This table shows the string representation of the word Newcastle. If we set our starting position for the substring as 3 and then the number of letters needed to be 4, we get the substring cast. This code demonstrates how to create the string Newcastle, extract the letter at position 3 and display the substring cast as described in our table example. Python actually does this quite a bit differently to most programming languages, where you would identify the start position and then the length of the substring. Instead, in Python we specify the start position and end position. Python also only slices up to the end position. It won't include the character at the end position. One reason why you might want to identify a substring is if you have a bunch of email addresses and you need to get the username from all the email addresses, the part before the @ symbol. So, a string is a collection of characters. A string has a length and each character has a position. The length of a string is the number of characters in the string. In Python, we use the len function to get a string's length. We can access characters in a string by position. We can identify substrings, or strings within strings, by their position as well as their length. In Python, we use the start position and end position to get a substring.